Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside and we will continue factoring quadratic trinomials. Now we are going to be doing ones that are a little more difficult with regard to, there's just more to do, or less to do depending on how good you are at them and what you're able to do. But now we have a quadratic coefficient that is not a positive 1. Now it's going to be something that is more than positive 1. And it'll remain that way even if there are greatest common factors. And we're just going to have to deal with it. Sometimes you got to factor them. Now, I'll let you know a couple things right now. Number 1, 24 practice problems. Number 2, I'm going to go about this with a mental approach. There is more than one way to do this, but the most efficient way is to do this through a mental guess and check strategy. You'll see what I mean, and you'll hear me offer more strategies as we go through with it. But number 3, this video will go on as long as it has to. If you feel like that you're making sense of what I'm saying here, that's good. Now, in order to do this, you're going to need to understand binomial distribution, foiling, very well, because what I'm basically going to be doing is foiling my way into the answer, distribution. So that's really important for this. All right, so now the first half of this will be factoring them, and the second half will be solving by factoring, but it's all factoring in the end. I think they're smaller numbers to start with and they build up. Now, one of the weird things with this kind of video, and it's not as big with the other ones because this one there's less work for me to show. I can show you work and I can show you the idea of what's going on, but I'm going to know the answer. Not that I know the answers now, but as I work out the problem, I'm going to mentally find out the answer before I give you the answer, because I want to give you basically a mindset that you're going to need going into it. And I'll give you ways that you can understand that some things can be filtered out and such. That's going to be part of the help for this. So I hope that makes sense. I'm going to dive into this here. And what you're going to see is problems right here where you're just going to factor, not solve, but just factor, and then the back end where you're going to solve for the variable by factoring. But all of these guys, your a value is greater than 1. And by that I mean when we're talking about ax squared plus bx plus c. This is a non-1 coefficient each and every time, even if there's a greatest common factor to start with. Let me first tell you what you are not going to do on these problems. You do not say what two numbers multiply to make 2 and add to make -5. There are a lot of reasons behind it, but first of all, there's nothing factorable there. But also what you need to consider with that mindset is that, this doesn't factor into some sort of p plus this times p plus that and whatever else, because p times p is p squared, not 2p squared. You have to understand that a 2p squared is diving into this. And that's one of the first things that we got to recognize. There is a way to do this with a diamond method, and you factor by grouping, it's what it's called. And it's just not what I'm going to do. I've thought long and hard about it. I've taught every which way, and the most efficient way is what you want to build into going into the future. And in the future, best case scenario is understanding what's happening here most rather than just following a process. So understanding what's happening here most, guys, factor each completely. First golden rule, once again, as always, is you look for common factors first. There is no common factor here because I can't divide the same number or variable among all 3 terms here. So that's fine. Second thing is we have to assume that it's factorable for us to work this thing out. That doesn't mean it will be. I will go ahead and tell you that every single one of these is factorable. That's a guarantee. But assume that it's factorable for you to work something out. Now, assuming that it is factorable, what do we know about what happens when we do factor quadratic trinomials? We know that they appear in this form like this. Something times something. And in order for this to work out to get a p squared, I do know it's some sort of p times p. Now, you might be saying, Mr. Robinson, I thought you just said that it's not p times p. No. I mean, p times p gets you p squared, but the thing is we need a 2p squared here. So that's the end thing, right? We need a 2p squared. In order to get the first term in foiling, in order to get the first term to become 2p squared, then these two need to multiply to give you 2p squared. So without a common factor being 2 outside here, that must mean that a 2 must exist inside one of these 2p's here, meaning there must be like a 2p like that. Because you know what 2p times p is? It is 2p squared. And that's that end goal thing. We are going to basically be building the factorization by understanding how it would distribute to become this. That's the end goal of it. We need to distribute it to become this here. So here's how it's going to work for you guys. I do know that if it's factorable, this is how it needs to present itself. Some sort of 2p times p. That's what gets us the first term. Then I'm going to kind of look at some factors of the last term here. If we know how FOIL works, the outside and inside combine, and we'll get to that, but the outside and inside combine to become the negative 5p, and the last term multiplies to become a 2. So this is where you get a little playful with what you have here. And the good news is, with the earlier problems, we're going to be dealing with a lot of what are called prime factors. 2 can only come from 2 times 1, and 2 can only come from 2 times 1 again. So the end goal for us is to construct some sort of version of this last term here with some 2 times 1, either a 2 here and a 1 here, or a 1 here and a 2 here, in order so that when we FOIL, when we get the outside and inside multiplied and combined with like terms, we get a negative 5. That sounds like a lot to say, but it doesn't take that much if you understand a couple things that's going on. And honestly, there really is only one thing for us to check in here, and I'll show you why in a bit. But let's assume for a moment that we test putting a 2 here and a 1 here. Now keep in mind, this is a positive product. That might not mean plus and plus though, because here we do actually have a negative sum. So actually, what I do know for one set of filtering here is the only possible thing to test here is a minus and a minus. I know for sure that these both have to be negatives because a negative times a negative gives us a positive. And when we do that outside times inside, we need 2 negative terms to add to a negative right here. We've discussed this before. And there are going to be some caveats along the way when we have a negative product, but with a positive product, we know that it's either going to be minus minus here, or in some cases a plus plus, like in number 4, we're going to have a plus plus. Now, let's try and multiply outside with inside, 2p times negative 1 and negative 2 times p, and combine those. That gives us negative 4p. Well, is negative 4p negative 5p? No, it's close, but close isn't good enough. No, it's not. So we know that that one's not it. All right, so apparently the placement of the negative 1 and the negative 2 are apparently in the wrong spot. Okay, let's consider putting instead a 1 here and a 2 here, or a negative 1 and a negative 2. So this is a little guess and check. It's a little trial and error, but I'll show you how I knew that this one was actually this one to start off with in just a moment. It's one of those strategies. Let's try 2p times negative 2 and negative 1 times p. Okay, that's going to give us negative 5p. Okay, so it looks like this is the final factorization, guys. We actually landed on the final answer. The final answer here being factor 2p minus 1, and p minus 2. Now I'm going to recap all of what I just said here, and I'm going to give you the strategy as to how I knew this was this, and it's not always going to be that easy of a thing to strategize, but with the prime numbers here, it was. So, what I did, to recap, what I just did for this set of problems was, I looked at the first term and said, how can I possibly get a 2p squared from here? The only possible way for us to do that, guys, is to do 2p times p. I suppose you can say p times 2p, but I'm always going to put the larger term here first just because it doesn't matter then, right? So I'm going to put that one first. Then I look at factors of the last term. Now this value was also a 2, so that can only come from 2 times 1, or of course negative 2 times negative 1, but the end result is it's not like 2 times 1 and 7 times. It's not a composite number with a bunch of things. It's just the number times 1. So 2 times 1. So I'm only testing so many different ways that I can put in the first and last terms, because we know that the first is this times this and the last is this times this. So we know that there are so many ways that we can put those together. It's either 2p and p with negative 1 and negative 2, or with negative 2 and negative 1. Those are the only possibilities. And the question comes into the form of, with the first and last in place, the way that we tested them, which ones will FOIL to give us the outside multiplied added with the inside multiplied and get us negative 5p. We need to find out which variation of our factors of the firsts with the last will give the outside and inside to become this here. And again, this video, guys, will go on as long as it has to. I'm still on the first problem here, and I guarantee you guys, I could have been done with the entire thing in this time on my own, but it's giving you the strategies here. So we're trying to find out which version of outside and inside, and I'll go faster along the way because you're just hearing it for the first time. Which version of outside and inside will get us the negative 5p? Putting a negative 2 here and a negative 1 here actually give us negative 4p. And again, I'm going to talk about that one a little bit more and why I knew that that wasn't the answer. But also, then testing that, we get negative 5p there. And there it was. So I'm working through distribution to get the factorization, if that makes sense. I'm distributing to factor. It's like, sometimes, like if I gave you, hey, what's 64 divided by, 4? You might, instead of dividing it by 4, you might try and think of what times 4 gives you 64. So I'm working in division, you're doing multiplication sometimes. Okay, how did I know that the answer was not ever going to be 2p minus 2 times p minus 1? Well, it comes as simple as this, and I hope that this makes sense. We established from the very beginning that this did not have any greatest common factors. There was no GCF of this here. We couldn't factor out a 2. We couldn't factor anything out. Well, as it just so happens to appear, 2p minus 2 does have a factor of 2. If this was your answer, that means this answer would have been able to factor the 2 out of this term. I was going to write a p. I would have been able to factor the 2 out of this term. I would have been left with p minus 1 there and p minus 1 here. And not to say that this couldn't be an answer to something, but if this didn't have a greatest common factor of 2, then this shouldn't have a greatest common factor of 2. I shouldn't be able to have common factors here if I've already established all greatest common factors out of here. And that's how I knew that. It wouldn't have been possible to have this here in that regard. Remember that this would have become 2p squared minus 4p minus plus 2? Well, look, this one has a greatest common factor of 2. See, I would have been able to factor out a 2 from the beginning. And you know what? I would have done that because that would have given me a 1p squared here. And this problem would have been a lot easier because I would have found out what two numbers multiply to make 1 and had to make negative 2, use the diamond or whatever, and go. Anyway, so my straight up realization was, hey, once I put a 2 here, I realized if this has a common factor, that's a problem because this didn't have a common factor or I would have already factored them all out. So there was only one possibility. The only one where I have the products of 2 that does not give me any common factors, and this was it. All right, 12 minutes on a single problem there, and we have 23 more to go. Does that mean I'm going to be spending 288 minutes doing this thing? Heck no. We're going to keep going forward. Now, the good thing about number 2, once again, is no common. I'm fine with common factors, but 5 is a prime number and negative 3 is a prime number. That's really good for this because there are only so many things that you have to test here. Later, they're going to get harder with some composite numbers, and you have to test other things. Okay, how do we do this? Look for greatest common factors. There are none. Move forward. Assume that it's factorable. So if it's factorable, that means that we are going to know that this is going to be some sort of v times v to get the v squared term. And because it's a 5, because 5 is a prime number, we know that the only possibility of getting it to 5v squared is doing 5v times v. So I do know that I can lock this in place, assuming it's factorable. Okay, the next stage here is this negative 3. Now this one can get a little, harder because I don't know where the pluses and minuses go immediately off the bat here. You got to play with some things a little bit. But 3, the number 3, comes from doing 3 times 1, or 1 times 3. And I state both of those because there's a difference between putting the 3 here and the 1 here, and the 1 here and the 3 here. And I don't think I made it obvious from the last one here. But you have to understand that when I put the 3 here, that's going to multiply by a 1v. And when I put the 1 here, it's going to be multiplied by the 5v. You can see that 5 is going to multiply by 1 here, and 3 is going to multiply, and 1's going to, this one's going to be multiplied by a 5, this 3 is going to be multiplied by a 1. But if I switch it, then the 5 is going to multiply with 3, and the 1's going to multiply with 1. So you can tell that this 5 here kind of changes the nature of, do I multiply the 5 with 1 or the 5 with 3? Because this one's going to multiply by a 1. You know what I mean? So anyway, now we got to play with, where does the 3 go? Where does the 1 go? And I really do only have two things to test here still. And I'll kind of tell you and show you why. You can even put, see, we don't know where the plus or minus goes. Is it plus or is it minus or plus? We don't really know here. But check this out, guys. I'm just going to put a plus and minus here. Whether or not it's right or wrong, I don't care. You'll see what I mean here in a moment. And by the way, I know that 1's a plus, 1's a minus because this is a negative product. 3 times negative 1 or negative 1 times 3. Let's go ahead and test this here. And this is without knowing what the answer was beforehand, or not entering these knowing what the answer was beforehand. Let's do 5v times negative 1. By the way, we're testing to get 2v. We're testing to get 2v. We know the first term gets us 5v squared. We know the last term gets a negative 3. Let's do 5v times negative 1. We get negative 5v. Let's do 3 times v. We get 3v. And what does negative 5v plus 3v give you? It's negative 2v. Now, is that 2v? No, it's not. But Does that mean that I should suddenly be going like, oh, that didn't work. Let's plug in the 1 here and let's plug in the 3 here and let's test that. No. Don't do that. Don't do that. You got something good out of this still. You got the opposite of your answer. And to sometimes I tell people, guys, that doesn't mean anything. No, it means a lot here because this is all just about sign changes. This sign changed as a result of these signs just being in the wrong spot. You know why you got a negative 2v? You got the correct difference of your values. Your values are just the wrong signs. You got a negative 2v because these signs are wrong. These signs are wrong because the pluses and the minuses are in the wrong spot. This should be a minus. This should be a plus. And me putting the plus in one versus the other, let's see if this works. Me putting the plus and minus in one versus the other was just saying just put them there because you know you're going to compute a difference because the negative product, the signs might be in the wrong spot. But let's try this now. Now we're going to get 5v minus 3v. And you know what that gives you? 2v. So the good news is, even if you get the exact opposite sign, that means all you got to do is change the sign. So there's still very limited testing if you know what you're doing with this. You just don't know automatically where the plus and the minus goes. So given that that's a 2v there, that would give you your answer. We know that the first terms give us 5v squared. The last terms give us negative 3v, or negative 3, I should say. And the middle terms now add to become a positive 2v. I don't even have to test the 1 and the 3 there. I am done. It is factored. And you can tell how what I'm doing here is going to speed things up a lot more. Now, the good news is these were prime factors. Unfortunately, at some point, we're going to deal with non-prime factors. That means more testing. But you'll see some more things I can do, more strategies to give you there. All right, let's try number 3, and let's do this a little bit more quickly, given what I just did from the previous one. No common factors here. I can't divide something among all 3 terms. However, I do know that if it's factorable, once again, it's going to be some sort of 5p times p. I really wish these were all x's, to be honest, but I can't really generate that on the fly. Now, the good news is also, again, that's 5b times p because that's a prime number. 7 is also a prime number, so I know this is some form of 7 times 1 or 1 times 7. I don't know which one yet. Let's try 7 times 1, just because. Because this is a negative value here, that does mean that one will be a plus, one will be a minus. So I'm just going to test this one. We'll see if it works. We need to test outside times inside. Sorry, outside multiplied plus inside multiplied, and see if we get 34. 5 times negative 1 and 7 times 1. 5p, negative 5p plus 7p. And I'll be honest, guys, at some point I'm not even going to say the p part. I'm really just trying to see if 5 times negative 1 plus 7 times 1 gives me 34. We know they combine with the p. Eventually, I'm not going to be writing this stuff. You're going to hear me say out loud more of my process and what I do. And I'm just going to be going for which combinations. By the way, that's 2p. That's not 34p's. That's clearly not it. It looks like the 7 and the 1 are in the wrong spot. The only way this is possible is if they are in these spots here. We might have to change the plus and the minus, but we have to see if these can go in this spot instead. So let's try this now. Now let's try 5p times negative 7, negative 35p, plus 1 times p, and that's negative 34p. We'll see it's not positive 34p, but it's negative 34p, and that's good. That means that everything's in the right spot number-wise. We just need to change these signs. This plus should be a minus, this minus should be a plus. So we should have a minus and a plus. That would give us 35p minus 1p. That gives you 34p. So this is the correct spot. This is the location. It is now factored. You can see how this gives us better best case scenarios of going faster with this compared to that if I know you don't know the other ways to do this. There's so many ways to factor these guys. But this is the mental guess and check factorization. And you can go without writing these things. Again, if you know how to multiply and you understand your concept of distribution, know the outside and inside work the way that they do, that's really beneficial to you. All right, number 4 here. Number 4, let's see. Do we have a common factor of 7, 35, maybe? Oh, no, 50. If this was a 56, then yeah, but it's not. And you know what? This shouldn't have a factor of 7 because we're not getting any 1, the a value being 1 ever. So, okay, we still are going to attempt to factor. Now, there's some good news with this stuff regarding the fact that everything's a plus. So check this out. I'm going to assume that it's factorable. That means I know that we'll have a 7b times a b. Once again, 7's a prime number. If 7's a prime number, there's only one possibility of it, and it's this. And here's something else that I know. Everything else is positive. That means I know this has to be a plus and this has to be a plus. The rest we got to play with here. This is our first instance of having a composite value here where we have to test more than one thing for 35, there are multiple possibilities we can have here. This might be 35 and 1, 1 and 35. Remember, it's different here because either it's 7 times 1 or 7 times 35, right? Which you might know already it's not going to be 7 times 35 to get you 54. Or it might be 7 and 5 or 5 and 7. Now, I can tell you which ones I know that it's already not going to be off the bat. If you remember what I said on number 1 about this not being a 2 because we couldn't have common factors here if there weren't common factors before, I can tell you already right now it is not going to be a 35 here because 7 and 35 would share a common factor. So there's no way it can be that. And there's no way, so that means it can't be this one. And there's no way it can be a 7 here either because 7 and 7 would have a common factor there as well. So there's no way it can be this one either. I hope that makes sense what I filtered out. So it's either down to a 1 and 35 being here or a 5 and 7. And I'll tell you what, I already mentioned this before, there's no way. This is just number sense, guys. There's no way that this is going to be 1 and 35. You know why? I got to add to 54. I'm going to do 7 times 35. You know what that is? Much more than 54. There's no way this is going to give me 54. The only possibility of this being factorable, guys, is if this is 5 and 7. I can't guarantee you that's the answer because it might be non-factorable. It might be I already told you these are all factorable. The only way, guys, is if this is a 5 and if this is a 7. Let's test it out. Let's see how that works. 7 times 7 is 49. 5 times 1 is 5. 49 plus 5 is 54. We got it. We got it. Now, all the stuff I said there is stuff that my mind does really fast. Not in an instant, but within a few seconds. My mind will filter out ones that I'm not going to bother testing because I understand the relationships of these values and how they work. That is strategy at its core that lets this guess and check go really fast in the long run. You can test all those values all you want, but the bottom line is they are not going to add to become 54, and there's only one unique set, and this is it. So we got that one there. Despite the fact that 35 was a composite number and I had to test at most up to 4 things, I knew I didn't have to test 3 of them. So those strategies, guys, those come with number sense. And that's why mental factoring is good. It helps your number sense. It helps you work multiplication. You're not just following a process. You are understanding what's actually happening here. That's the most important thing you can get out of this math stuff, guys. Understand, not just follow a process. Understand what's actually happening. All right, so see, those last 3 problems I only spent 10 minutes on were the first problem I did that. So you can see how it can speed up. However, number 5, we get a little instance of something different here. We have a common factor. I can factor out a 2. So when I factor out a 2 here, what remains inside? 3m squared plus 8m plus 4. So we factor the 2 out, but we're not done because we have to now try and factor this part here. And again, there's no more factoring down from here. This is not a 1m squared, so we got to continue what we did before. Assume that it's factorable. First of all, write the 2 on the outside. Assume that it's factorable and go to work like we've gone to work before. So a prime, once again, a prime number here. I know this will be 3m times m. Once again, we have all positive numbers here. That's nice and dandy. We know this will be plus and plus. And now we have a 4 here. 4 is either 4 times 1, 1 times 4. You have to understand those are different things because 3 either multiplies with the 1 and 4, or 2 times 2. Now, I know what it's going to be, not just through the mental multiplication, but because of something regarding this 8. I'll try and help you with what that is so we can use it for the future. You might not understand it the first time, but we'll see. I'll let you know right now that I do know it's going to be the 2 and the 2. But let's try and test some of these other ones so we can work the mental process of me not writing these things on the side. Let's see if you can understand what I'm going to do here. I need to do 3 times 1. I need to do 3 times this number, 1 times this number, and add them up and see if I get 8. So check this out. 3 times 1 is 3. 1 times 4 is 4. 3 plus 4 is 7. So it's not these ones because 7 is not 8. Let's try it again. 3 times 4 is 12. See, it's already too big. 12 is already more than 8, so it's already too big because you're going to be adding the 1 and you get 13, so it's already too big. Let's try this one. 3 times 2 is 6. 1 times 2 is 2. 6 plus 2 is 8. Okay, so it's 2 and 2. It's 2 and 2. 2's go here. We can get rid of the others. And there's the answer. So hopefully it's making sense what I'm doing still with regard to all that stuff. Now this is the full factorization of this part right there. That's the full thing. That is the final answer factored form. Mr. Robinson, how did you know that these were 2's and not 4 and 1? All right. Bear with me here as best as you can. This is... you know what? It would be worth testing some of those numbers because there are only 3 things to test. But if you have a multitude of numbers to test, maybe you got to reconsider. But here's what I know. This will dive down a rabbit hole a little bit, but I'm going to be mentioning this as often as I can whenever it pops up. 8 is an even number. The 3 and the 1 were odd numbers here. The 3 was odd, the 1 was odd. The only possible way that you can, and remember the even number also, 8 was a sum of 2 numbers. The only way you can get an even number is from an odd plus an odd or an even plus an even. 3 and 1 being odd numbers can only stay odd if both of your numbers here were odd. Odd can only come from, and yes, I did all this on the fly in my head. Odd comes from only doing odd times odd. If you do odd times even, you get even. If you do even times even, you get even. Now, our factors of 4 are either 2 and 2, both even numbers, or 4 and 1, 1 even, 1 odd. It's impossible to get a case of an odd plus odd because we would never stay as an odd times odd, because one of the factors being even, at least one factor being even, would either mean one is even or both are even, which means you could never get an odd plus odd because these were odd, yada yada. I know I'm stating a lot. I really apologize about this. The only way that this is possible to get even is from even plus even. And the only way to get evens from odds is to be doing odd times even. Odd times even equals even. You know what 2 is? Even. Even and even. So I'm doing odd times even is even. Odd times even is even. See, if I did 4 and 1, that would be doing an odd times an odd. That's an odd. And then odd times even is an even. Odd plus even is not even. It's odd. Or if I did 1 and 4, odd times even is even. Odd times odd is odd. You have even plus odd again. Yes, I knew from the very beginning that I needed an even result and these were odds. The only way this is possible is if these were evens, because 4 doesn't have any double odd factors. Yes, that was a lot to state, and maybe that's too much for you guys. But that strategy gets me whip immediately fast into getting that answer of 2 and 2. If there is any time to cut out, you consider anything that you can, especially if you have a multitude of options. Listen, guys, our numbers are not going to stay as small as 4. What if you get numbers like 64? Now you have factors like 1 and 64, 2 and 32, 4 and 16, and 8 and 8. That might be it. Never mind. They're good, but you have to reverse all those. 64 and 1, 32 and 2. So there are a bunch of things you're going to have to test after that. So anything you can to whittle it down, any strategy possible, you go for. You go for. And anyway, that's the answer then. All right, let's go on to number 6. And like I said, guys, this video will go on as long as it has to. It's almost the half-hour mark. 5 problems in. Let's keep going. Number 6. 6m squared plus 45m plus 75. I'm sniffing a common factor. I assume it's got to be 3 because these are, once again, 6 is an even number, 45, 75 are odd numbers. 6 is not going to be the number. And as I've mentioned before, we're not going to get down to a 1m squared. I'm sniffing out that 3. I do believe all these can divide by 3. So we're going to be left with 2m squared plus, 15m plus 25. All right, here we go. So there's that factorization of that part. Now let's assume this part's factorable again. One more time, guys. We're dealing with the principle of we got a prime factorization here. So we know this will be some sort of 2m times 1m right there. And we do know, once again, with pluses, you get a plus and plus. All right, we've dealt with those several times now. Hopefully you're comfortable going back to the minuses when we hit them on, let's say, number 8. But here we go, plus and plus. So what are our options to get 15? Either 25 and 1 or 5 and 5. And guess what? All those are odds, so your result, no matter what, will be some sort of thing with that. Now, I know it can't be 25 and 1, or 1 and 25, because 25 is just too big. Our sum needs to be 15, and we're going to be adding our results. If I do 2 times 25 or 1 times 25 and I add something, it'll be too big. It can't be either of these. You don't need to check them. The only possibility here is 5 and 5. And let's try it. 2 times 5 is 10. 1 times 5 is 5. 10 plus 5 is 15. There it is. We're factored. We're done. That's it. I didn't even bother with the other ones. I understood. See, I didn't do it in full. I just understood 25 was too big no matter what was going to happen. So I don't call that testing it. I say I observed. I observed what was there. And by the way, the 3 stays on the outside with factorization. So you can see how this goes relatively fast. And again, in comparison to the other methods, these scenarios can go really fast depending on what you're doing. All right, number 7. Let's look for common factors. I don't think we're going to have one here. 19 is a prime number, and we got evens here, yada, yada. So we're going to deal with just factoring from here. Now, this one gets a little trickier, guys, because for the first time, we are dealing with a composite quadratic coefficient. That means, and check this out, that means there is a multitude of options that we may have to try from. I'll show you that we don't have to do both of them, though, but listen up. We know that an m times m is going to happen here. We know that an m times m is going to happen here. But the question is it 4m times 1m or is it 2m times 2m? See, this is where things can get a little tricky. You're sometimes going to have to test more than one thing. But if you heard what I talked about with the odd and evens, you're going to realize you don't have to test multiple things here. If you recall, you're going to try and find numbers that add to negative 19 in the end. And you're going to have to choose things in these numbers that multiply with 12, which, by the way, have a multitude of different things to try. Now, check this out. 19 is an odd number. Odd number only comes from even plus odd, or even minus odd, what have you. It can't come from odd plus odd or even plus even. You know what happens when you have 2's here, even numbers, and you multiply them with other numbers, whether they're odd or even? The result is even. If I do 2 times something, I'm going to get an even number, and 2 times something, I'm going to get an even number. Even plus even cannot give you odd. Once again, even plus even cannot give you odd. This cannot be 2 and 2. I don't even need to test it. This is why these strategies are important. You are reducing the amount of testing. For all I care now, 4 is a prime number to me because I don't even need to try its other factor. I just get to try 4 and 1. Awesome, that's good. What else do we know about this? Positive product, negative sum. That means we know that we're going to have minus and minus here. Okay. Now, once again, guys, this is one of those things where I got the answer in my head a long time ago. I didn't even try to, but it's one of those things where I need you to hear out what it is that you can do to strategically filter out things and not have to test as much as you need to. Now, 12 has many factors, guys. It has enough, right? What could we potentially test? We could potentially test as much as 12 and 1, 1 and 12, 6 and 2, 2 and 6, or 4 and 3, 3 and 4. Let's take out ones that is not going to be. It's not going to be 12 and 1. Here's how I know this. 4 and 12 have a common factor of 4. If this didn't have a common factor, this shouldn't. You leave it out. You get rid of it. That is also true of any even numbers. 6 and 2. And by the way, it can't be 6 and 2 or 2 and 6 because 6 and 2 are both even numbers. When you multiply any number by evens, you get evens. This result is odd. It couldn't have been these in the first place. Never mind the fact. It couldn't have been these in the first place. Never mind the fact that 6 and 2 have common factors with 4 of 2. And this couldn't have been here in the first place either. And it can't be 4 for that same very reason. 4 with 4, that's not going to work. You can't have a common factor here if you didn't here. So you're now down left. You're left to either the 1 and the 12 or the 3 and the 4 here. It's not going to be 1 and 12 because 4 times 12 is just too big. That's negative 48. It's not going to get you back to negative 19, so it's not going to be this. The only possibility, guys, I narrowed this down. And keep in mind, you would have had to test these 6 different sets with this right here. You could have had to test up to, listen, you could have had to test up to 12 different things. And I'm only going to make you test one of them, 3 and 4. You could have tested up to 12 because you would have tested these 6 here and these 6 here all the way to this bottom one. And we're just going to test this one. And if this doesn't work, then we know it's prime. But guess what? 4 times negative 4 is negative 16. Negative 3 times 1 is negative 3. Negative 16 minus 3 is negative 19. The answer is this one here. So when I say guess and check, there is an educated way of doing it. And if you're listening to me on this, and if you're understanding, I hope you're not blowing past these and saying, yeah, he's just talking and talk. No. I'm saving so much time. by not testing those things. I'm saving all the time in the world by not testing those things. And that's something that you want to keep trying strategically. And I'm not going to stop short of that. But I'm going to be saying, I'm going to be writing a lot less over time once we start hitting more problems of the same variety, guys. You've heard the things about even and odds. You've heard the things about common factors. You've heard the things about minuses versus pluses. When I run into another problem that's of the same ilk next time, you're going to start to understand how you can test less and less things over time. It's not always down to just testing one thing. Sometimes I have to test a multitude still, but there it is. All right, number 8, common factors. Nope, no common factors, so let's start to break this thing apart. Now, 4, once again, is a prime value. Excuse me, prime, it's a composite value. So it's either going to be some sort of 2 times 2, or 4 times 1. So, let's start with some considerations and ideas here. If it's some combination of 4 times 1, right, 4k times k, if it's some sort of combination of that, then that means that, we're going to test factors of 15 here where we go through and through. Now, this is, if you know, an even number. This is an even number. 15 only has odd factors. You have 15 and 1, or 1 and 15, 5 and 3, or 3 and 5. 4 is an even number. 1 is an odd number. If I do even times odd, I'm going to get even. Odd times odd, I'm going to get odd. Even plus odd is odd. There is no way that with only odd factors here, and with 4 and 1 being odd and even, there's no way I'm going to get an even result by testing any of these or their reverses right here. It is impossible that I'm going to get not only a 4, it's impossible I'm going to get an even result from this. So I know it cannot be 4 and 1. Let's try 2 and 2, because you know what happens when you have 2 and 2? No matter what they multiply by, I'll get evens, and an even plus an even's an even. So I know that this is the only way to test this, with the 2s. The other one was with the 4s, was with 4. And keep in mind, guys, I haven't seen these answers. I'm telling you outright what it is I can avoid testing. Sometimes it's going to be impossible to avoid testing all this stuff, but this stuff has been working out with us so far. Now, none of these have common factors with the 2, so that means that these are all potential to test. Keep in mind, though, when you are testing, consider that with a negative product, one's going to be positive, one's going to be negative. Are they in the right spot? We don't know. We'll talk about what happens there. Now, also keep this in mind, guys. This is where you work a little bit of your kind of mental strategy. 2 is multiplying these in the same way, so it doesn't matter now. See, I don't have to try. If I try 15 and 1 here, I don't have to try 1 and 15 here, because 2 is already multiplying. It's 2 times 1, 2 times 15, or 2 times 15 and 2 times 1. So I don't have to test these again because those were 2 and 2, right? I only have to test them once. Either I'm going to land on them here, or I'm not going to. And I'm already looking at that 15. I'm thinking that 15 is going to be too large, but let's try it anyway. 2 times negative 1 is negative 2. 2 times 15 is 30. 30 minus 2 is 28. Way too big. It wasn't going to be this. So there was really only one thing I was going to bother trying to test first, and that was 5 and 3. Now, this might not be the answer because I might have to switch the signs, but I do know that if it's going to work, it's going to be with this 5 and 3. So let's try it. 2 times negative 3 is negative 6. 2 times 5 is 10. 10 minus 6 is 4. Positive 4. So these are not only the right numbers, but they're with the right signs as well. So 5 goes there. 3 goes there, and we have the right signs with the right numbers. That is the answer. And again, guys, I tested something else, but I didn't really. I had no belief that it was actually going to work. I only tested one thing instead of testing at least 8 if you did everything. All right, let's go forward. Common factors? I don't think so. With these being even and that being an odd, I don't think so. So now we have 10. All right, well, 10, see, 10 is an instance where we have either 10 times 1 or 2 times 5, and odd times an even in both cases. This one, we might not be able to luck out as much being able to play with that odd even scenario, but we might be able to with the 42. This one might take a little more testing. I'm just going to let you know right now. This one might take a little more testing. I don't know this one off the bat. I can possibly stumble upon the answer, but I don't know. We're going to have to talk it out a little bit. So let's consider some tests. Maybe strategically we can stumble across something that'll help us. As of this moment, I don't know, but what I do know is that 53 is kind of a large number. So let's just work some things out. I'm not convinced fully that's going to be 10 times 1, because 10 times something. Oh, you know what? It could be. I don't know for sure. Actually, you know what? Now I got the answer in my head. Actually, it is going to be a 10 and a 1. Okay. So anyway. So I'm going to try 10 with 1 here. There's a possibility, guys, that it could have been some sort of 5a with 2a. Just keep that in mind. It could have possibly been this. And this is where you can do some testing. Now, because of the negative product, we are going to have some sort of form of plus and minus. Are these in the right spot yet? We don't know. We're going to have to play with it. Now, 42. 42 comes from what? There's 42 and 1. 21. And flipping it, by the way. 42 and 1. 1 and 42. We have 21 and 2. 2 and 21. 14 and 3. Yeah, 14 and 3, 3 and 14. You can see where this can get a little heavy, right? This one takes a little bit more. Divided by 4, no, 5, no, 6, 7 and 6, and 6 and 7, right? So just going down the list. Now, this is one of those cases, guys, where once again 42 is a combination of an odd times an even and things like that. So we are not really going to luck out in any sort of way, with the exception of if you are testing these. If you do odd times even and odd times even here, you'd be left with evens and evens. So ones that I do know that I can filter out, guys, is doing the odds times evens, because we need an odd result. So I know I can factor out this set here, because so anything with even on this side and odd on this side I can factor out. So we can take out, oh, by the way, another reason we can take these ones out, actually, I should just mention this, is because this is an even number, and 10 and 42 have common factors with each other. 10 and 2 have common factors with each other. 10 and 14 have common factors with each other. 10 and 6 have common factors with each other. So we know that anything there, that's probably another reason why that wouldn't work. But yeah, 10 common factor with these, at least being able to factor out a 2, means that it couldn't have been these ones anyway, because this didn't have a common factor. So we pull from that and go from there. So we test some things, right? 10 times 42, no, that's negative 420. There's no way that's going to go there. I'm not going to try that. All right, let's try some others. 10 times negative 2, so negative 20, and then 21, and 1 times 21 is 21. So negative 20 plus 21, that's 1. So no, it's not that. So I'm actually testing right now. I'm actually testing them. 10 times 14, ooh, that's pretty big. That's 140, negative 140. That's not going to get us to 53 with the 1, so that's not going to work. 10 times negative 6 is negative 60. 1 times 7 is 7. Negative 60 plus 7. Ah, that's negative 53. Okay, so that's the answer. Hey, listen, I already knew that. I'm saying it. Hopefully I'm a good actor. Like, that's negative 53. Nice. There it is. So, I had to test a few. There were some that as I was testing it, I said, yeah, that's not going to work. So I'm not testing, I'm not writing things out, right? I'm not testing it in full. I'm giving myself that opportunity. And listen, it very realistically could have used the 5 and the 2. One reason why the 10 maybe could have worked is you have to recognize the fact that 53 is a pretty big number. If you need to get to negative 53 from a difference of values, maybe multiplying by 10 can get you there. But of course, multiplying, say, 5 by 21 or by 14 could also possibly get you there. So it was a very realistic possibility these ones could have worked. But you saw what I had to test and filter, and we got there. Arguably, so far, definitely the hardest problem as far as things you got to definitely try and test. Composite values here and here, and go from there. All right, number 10, which actually might be an easier problem than number 9 here. Number 10, we have, because we have a prime here, so that's very good. So no common factors though, right? No common factors. So we're either going to be doing, see with 9x squared, that's either 3x times 3x or 9x times 1x. All odd numbers there. So we probably can't luck out in talking about factoring. So the good news of 3x times 3x, and the reason I'm going to try this one first is because you don't have to switch numbers when testing 2 and 1, because you're going to multiply one with 3 and the other with 3. So I know it's a negative 2, so let's try the plus and minus here. And it's either going to be 1 times 2 or 2 times 1. But here's the thing, I don't need to switch them, because 3 times 2 here or 3 times 2 here doesn't change anything. So let's try this first, see if it gets us any form of positive or negative 3. And if it doesn't, we'll move on to the next one. We'll try 9 and 1, right? So just try it out. Negative 6 plus 3 is negative. So the first one I tried, and it worked. And I didn't know. I didn't know because I was saying it all with you. I could have tried 2 and 1 here, and that would have given me a positive 3, and then I would have known to switch it. But those were the only 2 values to even try testing. And then, that would have been it. Then I would have gone to the 9s. But I said it's worth testing here because you either try it and it does or doesn't work. And if it doesn't work, you move on. So anyway, this one did work. That was actually the final answer. The signs are even in the right spot. I put the plus minus, I tried them, and they're there. Good to go. So you can see thought process there, guys. Sometimes I land on them, sometimes I don't. All right, number 11 here. We do have a negative, so I absolutely have to factor that negative out of that thing. I'm not going to go with a negative on the inside. But it looks like we have a common factor as well, a 2, a 6. You can factor a 6 out of here. Is that the largest? 12, no, not 12, 9. I think 6. I'm going to see if there's anything left here. We factor out a negative 6 from here. Let's see what remains inside. Negative 6 times positive 8 is 48, so 8x squared. And then this will be negative 10x, and then a minus 3 there. Again, negatives times these change the sign. So yeah, no more common factors. This is what we're left with inside. And let's go to work from there, shall we? We shall. Let's go. So the negative 6 will stay on the outside. Assume this is factorable here. I'm glad I have x's again because I just think that x's are just natural for these things. Okay, what have we mentioned before here? So 8. 8 can be 8 times 1 or 4 times 2. The 3 being odd numbers only, though, and the 10 being an even sum, means this either comes from odd plus odd or even plus even. We're not going to get an odd plus odd given that 8 is in either 8 times 1, 8 being an even number times an odd, da-da-da. So I know that the only way to get this is from even plus even. We can only get that with 4 and 2 because these are odds. The 3 is odds, only 4 and 2. I know I don't even have to test the 8s. That's me and my knowledge with that. I explained more than I thought about that. I know these are the only possibilities. I'm not going to bother the others. So 3 and 1. Plus and minus, I'll try that first. Let's try either 3 and 1 or 1 and 3. One of these will work. Which one? Let's find out. 4 times negative 1 is negative 4 plus 6. Negative 4 plus 6. That's actually not negative 10. That's positive 2, right? So it's not that one. Let's try this one. Negative 12. 4 times negative 3 is negative 12 plus 2. Negative 12 plus 2 is negative 10. And I don't have to change these signs. So there it is. I only tested 2 things there. I didn't have to flip anything else. Didn't have to try the 8 and the 1. I'm good. And if you tried the 8 and the 1, that's not too much more testing beyond that. It's a couple more things. But didn't have to change the signs either, right? Don't bother with that. There's the final answer. All right, and last one on this side, guys, number 12. And after that, I'm going to go a lot faster on the other side with the factoring. And I'll explain things out loud, but that testing stuff, I hope I've run into the majority of the kinds of things that you'll see. I guess problems could get more robust with the way that they're written, but I don't know. These numbers are pretty big here, but we got to find greatest common factors first, absolutely. 68, I think, can divide by 4. Can these divide by 8? 68, that can't divide by 8. So let's try 4 first, or a negative 4. Let's box this. Let's try a negative 4 first and see if anything can come from there. 68, I don't know 68 with many other numbers larger than negative 4, so let's assume it's a negative 4 for now. So I got a 10x squared, also a composite value. That is 17, plus 17x, yeah, 17 there. And then minus 20. Okay, so 10x squared, 17x minus 20. So there might be some extensive testing here because factors of 20 are in odd times and even, factors of 10 are in odd times and even, and we got the 17 here. We know some things we'll try that we won't have to try as far as factors here. I'll give you the long list and I'll tell you ones that I don't need based on common factors of my factors of 10 and 20. So let's consider every option here and cross out the ones that won't even need to bother being tested. So I'll try it with 10x and x, and then we'll try it also with 5x and 2x, and then we'll just try things until they don't work. And this is where some other people can argue that there's maybe a faster way to do this problem here. Depends on how, worst case scenario, you might have to test a few things until it doesn't work here. But I'll show you which ones, I'll write all the ones out and cross out which ones we don't need. What are factors of 20? Oh, by the way, plus, minus, right? Because the negative thing there, so plus, minus. So either 20 and 1, which I already know that won't work, 1 and 20, 10 and 2, 2 and 10. I'm sorry, 20 can have even factors as well. But I already know those won't work because 17 is the odd number, right? Or I should not say those yet. 5 and 4, 4 and 5. Okay, those are the ones on that one. And here we go. Let's try those with these. 20 and 1, or 1 and 20. 10 and 2, or 2 and 10. Now remember, I wouldn't write these out for myself. I would mentally plug those in my head and say, could I, don't need to, could I, don't need to, could I, don't need to. 5 and 4, 4 and 5. Okay, let me tell you which ones, without even trying the numbers to see if they add 17, let me show you which numbers won't work. Remember, we don't have any more common factors in here. That means if common factors exist within any of these terms here, they're gone. 10 and 20 have a common factor. Nope. That's possible. 10 and 10 have a common factor. Nope. Furthermore, these are evens. We can't get an odd from evens here. So definitely nope, definitely nope. 10 and 5 have a common factor. Nope. 10 and 4 have a common factor. Nope. The only one I'm going to possibly test from these is that one. 5 and 20 have a common factor. Nope. 2 and 20 have a common factor. Nope. These are evens. Nope, nope. 5 and 5 have a common factor. Nope. So the only possible ones I'm going to test here, guys, the only possible ones I'm going to test are 10x plus 1 and x minus 20 and 5x plus 4 and 2x minus 5. And by the way, remember, we might have to switch signs here, but even if we get a negative 17, we know what's going to land with it. So let's start with this one. 10 times negative 20. Pfft. Negative 200. Nope, that's not going to get us to 17 with that thing. Nope, not even going to try the rest of it. The only one that's possible that I'm even bothering trying to actually calculate 17 is this one. Despite the fact that there were, once again, 12 things to possibly test, I'm down to 1. We're going to see if it's going to be this. Here we go. Oh, or swapping the signs. But that's after doing the calculations. The calculation's the long part. Let's see if it's this. 5 times negative 5 is negative 25. 2 times 4 is 8. Negative 25 plus 8 is negative 17. This is a positive. All we need to do is swap these signs. Voila. Everything else I wouldn't have ever bothered testing because the common factor things and 10 times 20 is just too huge to get back to 17. There is your final answer for that one. So as bad and long as that could have been and might have looked, that's what that comes from with that. All right, that's the front side, guys. And yes, I spent 52 minutes on that front. I won't spend 52 minutes on the back. What this does involve, as the previous problems that we've done before with these things, is finding a greatest common factor potentially, or making sure we're in standard form, set equal to 0, possibly finding greatest common factors, then factoring them out, and then using zero product property to solve the rest. I'm going to make my factoring a lot faster now that you've probably heard the majority of the different kinds of ways that we test, where I'm not going to write as much. I will say as much possibly, but I won't write as much with it. I still would be able to factor a lot faster given if I just did it in my mind though, but I want to tell you why certain things don't work. And hopefully you can do those as well. All right, here we go, guys. If factorable, and so we're in standard form set equal to 0, so we're going to attempt to factor. No common factors here, so if factorable, we know this will be some sort of 3v times v to get 3v squared. And 5 is also a prime number, which is good. We also know this is plus and plus. So we're either going to try 5 and 1 or 1 and 5. We need to get up to 16 here. It's better if we multiply the 3 by the 5 to get it larger. And yeah, that's what I'm going to test here. 3 times 5 is 15, plus 1 is 16. There's that result. That's it. Set equal, that's it for factoring. Set equal to 0. Now we use the zero product property. If a times b equals 0, either a equals 0 or b equals 0. Now you know me, if I have a linear coefficient of 1 inside here, I know the answer is already just going to be the opposite of the 5. It's going to be negative 5. So let's start with that one. Subtract 5 from both sides. V is negative 5. And you're often probably not going to see me even write this stage for this one. This one, even though I do know it mentally, this one takes a couple more algebraic steps. Yeah, you subtract 1 over here, but that's when 3v is negative 1. Divide both sides by 3, you get v equals negative 1/3. So v either equals negative 1/3 or negative 5. And that's it. We move forward. All right, number 14. Once again, we're blessed with, even though there are no common factors, we're blessed with a prime and a prime right here. I have 2p times p to factor this thing with to get 2p squared, right? Positive product, negative sum, I know this is a minus and minus. So the question is it a 3 and a 1 or a 1 and a 3? Let's try 3 and 1. And I'm not writing it out. I'm doing this in my head. 3 and 1. 2 times negative 1 is negative 2. 1 times negative 3 is negative 3. Negative 2 minus 3 is negative 5. I actually, honestly, I was thinking it was going to be the other one because I was thinking of negative 6 plus 1, but I forgot they're both minuses. So actually, I was trying the wrong one first. I thought I was going to try the wrong one first. So -3 and -1 there. My bad that I landed on the right one. Anyway, so it does factor that, right? -2 minus 3 is -5. All right, that's what it factors out to. So if 2, let me change the color here. If this times this equals 0, either 2p minus 3 equals 0, either 2p minus 3 equals 0, or p minus 1 equals 0, therefore p equals 1, right? Or that. So add 3 to both sides, we get 2p equals 3. Divide both sides by 2, you get p equals 3 over 2, 3/2. So yeah, guys, this backside after you factor zero product property, this is where we anticipate that we get a little better with the factoring, a little faster, so it saves you time on kind of doing the rest there, which is what I'm saving time on now as I talk to you about it. All right, number 15, set in standard form set equal to 0, no common factors. Let's go to the factoring. Let's try 7x times x because 7 is a prime number there. And because and listen, the only way this is possible, positive product negative sum means negative negative. 1 is only possible with 1 times 1. If this isn't it, then we can't factor it. Let's see if that works. 7 times -1 is -7. 1 times -1 is -1. -7 minus 1 is -8. All right, that's it. That was the only thing we could test. If that wasn't it, it wouldn't work. All right, so there we go. So either 7x minus 1 equals 0, or if x minus 1 equals 0, then x equals 1. So here we go. 7x minus 1 equals 0. Add 1 to both sides. Divide both sides by 7. You get x is 1/7. There we go. Either x is 1/7 or x equals 1. See, we're going through this pretty fast here. All right, standard form set equal to 0. No common factors. And I do have a composite value here, although this one's prime. That's nice to work with. So let's work with it. We do know that this, if factorable, is some sort of 3n times n right there, set equal to 0. This minus here means we're going to be testing some sort of plus minus form. I might have to change them, but you know what? We'll deal with it. Now, this is an odd result, and this is odd times even. So we are going to have to test. So, well, actually, no, we're not going to have to. 6 is either. So I'm going to write this one more time for you just as a reminder, especially if you're watching this on a different day after watching the first one. This is either some form of 6 times 1, 1 times 6, or 3 times 2, 2 times 3. You have to remember that if this didn't have a common factor, this shouldn't have a common factor. 3 and 6 have a common factor, so that can't work. 3 and 3 have a common factor, so that can't work. So you have one of two options, either this one here or this one here. Let's try 1 and 6. -18 plus 1. Now that's not -7. -9 plus 2. Yeah, that's -7. So it's going to be this one right here. So you see how fast I'm doing that part as well, though. I understand the concept of FOIL. I know what's multiplying and what will combine. And I know my multiplication and addition. So I'm trying those. And there, it pans out. So I only tested at most 2 things. At most, I tested 2 things. The second one was it. Oh, and by the way, I didn't have to change the signs here either. It was -7. So there we go. There's factorization. So now either 3n plus 2 equals 0, or if n minus 3 equals 0, then n equals 3. If 3n plus 2 equals 0, subtract 2. I'm going to try one mentally with you guys here, because I know this is -2/3. When you subtract the 2, you divide by 3, right? So 3n equals -2. We do know that part switches. And then divide by 3, n equals -2/3. Not much space to write these parts here. I apologize, but I want to get as many practice problems with you as possible. All right, number 17, standard form set equal to 0. We do have a common factor. We do have a common factor of 2 here. If I can factor a 2 out of here, I'm going to have 2a squared plus 1a minus 1 equals 0. If you divide both sides by 2, because remember, that 2 is really irrelevant to this. If it helps you, just kind of work from here. Divide both, let me write it. Divide both sides by 2, and then the 2's cancel here. Because it's an equation, you can do that in an equation. And 0 divided by 2 is 0. Now you're just working with this part here, just the 2a squared. Whoops, I don't want to write anymore. Just the 2a squared plus 1a minus 1 equals 0. Okay? All right, if factorable. Now listen, this is one of those really straightforward, either it works or it doesn't, although we might have to change the signs here. But 2 is either, it's a prime number, so 2a times a. And 1, so it's -1 though, right? So plus and minus. So these numbers have to be 1 and 1, but are they in the right order? 2 times -1 is -2 plus 1. That's a -1. We need a positive 1. So what we have to do is just switch this plus and minus here. So that was the only thing that needed to change there. So minus and plus, right? 2 minus 1. There we go. So this is the factorization there. And if that's the case, either 2a minus 1 equals 0, or if a plus 1 equals 0, then a is negative 1. Hopefully you know what I'm doing with that every time I say that. You can write out a plus 1 equals 0. Please do so if you need to. Add 1 to both sides. 2a equals 1. Divide both sides by 2. A equals 1/2. And by the way, I haven't double checked any of these things with you. I'm definitely not going to double check the fractions. You can always try it. But the bottom line is, if you substitute 1/2 into a in here, you will get 0 on the left, 0 on the right. That's what's happening. All right, number 18. 9b squared minus 29b plus 6 equals 0. No common factor there. I can't divide 29 by 3. So it looks like we're dealing with what we have there. And these are composites. 9 is composite, 6 is composite. So we're gonna have to play with this a little bit. Now, 9 either comes from 3 times 3 or 9 times 9. So let's start exploring this a little bit. 9b and b, and this being an odd number, 6 being, there's not much I can say on the even odd front. What I can say is I'm not going to bother trying things that should have common factors, meaning 6 is either 6 times 1, 1 times 6, 3 times 2, or 2 times 3. I'm not going to put the 6 or the 3 here with the 9 because that would be common factors with them, so I'm not going to bother with that. In fact, I know that this couldn't have been now 3b with 3b. I didn't bother looking at it yet. This can't be 3b with 3b because 6 is either 6 times 1 or 3 times 2, and 6 and 3 have common factors with 3 here. So the 3's never would have worked here. This wouldn't have been possible for the 3's. So it has to be the 9's, right? And we know it's a minus minus because positive product, negative sum. So this is either a 1 and a 6 or a 2 and a 3. Let's test both. 9 times negative 6 is negative 54. Yeah, good luck getting back negative 29. I'm going to say that's already not it. 9 times negative 3 is negative 27. 1 times negative 2 is negative 2. Negative 27 minus 2 is negative 29. So there it is. There's our factorization. Let's get it as all big blue. All right. So let's go ahead and solve. Here we go. Either 9b minus 2 equals 0, or if b minus 3 equals 0, then b equals 3. If 9b minus 2 equals 0, add 2 to both sides and divide both sides by 9. You get b equals 2/9, or b equals 3. There we go. All right, number 19, standard form set equal to 0. Good. Let's go ahead and see common factors. We can factor a 2 out of here. And if I factor a 2 out of here, I could also divide both sides by 2, which I'll do here in just a moment. If I divide both sides by 2, the 2 goes away here, and 0 over 2 is 0, so you're left with 2n squared minus 3n minus 2 equals 0. Let's go ahead and try and factor this one. Thankfully, 2 is not only composite numbers, but it's the same number twice. So we have 2n times n as our possibility there. It's a possible plus and minus here. I don't know which one's which. Now, 2 is either 1 times 2 or 2 times 1. I can't put 2 times 1 here for 2 reasons. Number 1, common factor with that 2. Number 2, that would have been even times in odds and even, odd times in evens and even plus and evens and even. We can't get that. The only possibility is if this is the 1 and this is the 2. I don't know if this is the right order with the signs, but let's see. Negative 4 plus 1. That's negative 3. That worked out. There it is. So there's the factorization. So zero product property says either 2n plus 1 equals 0, or if n minus 2 equals 0, then n equals 2. So if 2n plus 1 equals 0, n should equal negative 1/2. There it is. This or that. 5 more problems. See how fast this part's going now that I've gotten the factorization talked about? You see how fast this can possibly be done with it. All right. 74. I don't think you can divide that by 4. So common factor of 2 is my guess. You can't divide 14 by 4 either. What am I talking about? You can't divide it by 7, though. Okay, so common factor of 2. Common factor of 2. So let's factor the 2 out of there. And then we have 7x squared minus 37. X minus 30 equals 0. I don't know if this will be a big boy problem or not. I'm dividing both sides by 2 there. It's just kind of getting the 2 out of the way. It's just kind of not needed. I don't really need it there. All right, this is going to be some form of 7x times x, right? Maybe a plus minus here, or maybe a minus plus. I don't know which. 30 has several factors. 30 times 1, 15 times 2, 3 times 10, and 5 times 6. So a couple things there. With odds here, so listen, with odds here and an odd sum, I want to avoid choosing, oh, never mind. I guess there's nothing to avoid here because every time I do 30, it's some sort of odd times even, I think. So there's nothing to avoid there. It is a little bit more extensive testing on this one here. It actually is. I don't think I'm going to bother with the, oh, actually, you know what? So listen, I wasn't going to bother putting a 30 here because that would do 7 times 30, but I could bother putting a 30 here, and actually I think this is the one that, no, you know what? That one doesn't work, actually. I was hoping it was 30 and 7. But this is negative 49 plus 30, so that does not work there. So, okay, so yeah, let's just try a couple numbers here. Plus no factors are common factors with 7. Now let's try something like 5 and 6, 6 and 5. So this is negative 42. Oh, I think this one works. This is negative 42 plus 5, and that's negative 37. So listen, I landed on it. I don't know why I tried that before 15 and stuff, honestly. Sometimes I didn't know that was going to work. And it just did. So, okay. Sorry. All right, so either 7x plus 5 equals 0, or if x minus 6 equals 0, then x equals 6. If 7x plus 5 equals 0, then 7x equals negative 5, and x equals negative 5 sevenths. And here's the thing, guys. Listen, I mean, I'm a math teacher, right? So given my math prowess, I'm perfectly comfortable testing multiple numbers at a time in my head until it works. I'm just trying numbers until I say, yeah, is that 37? Is that 37? I'm doing it whip fast when I get it done. So I know some people aren't as comfortable with it. Some people literally have to use a calculator each time, especially when the signs change or you're dealing with negatives. I get it. It happens. So some of these can be everlasting for you. But that's not unreasonable, and that's something that's expected for you to be able to do, even with numbers that, and I'm not saying large. 7 was still a prime number, so it wasn't the worst thing. All right, here we go. This time it's not set equal to 0, so we have to set it equal to 0. I'm going to add 2 to both sides there. Set it equal to 0 before we continue forward. And now we get 2v squared minus 3v minus 2 equals 0. Oh, I thought we had this factorization before. Maybe on the other side. I could have sworn. I was going to say I thought we had things with 2. No, we did have things with 2. Where is it? Did we do this one? 2 and 2? Where is it? Oh, it's right here. So, after you factored it out. So, hey, I didn't mean to do this. I'm sorry. I would have preferred you actually tried something else. But we had, instead of a v, we had an n. But this factored, right here. This factored to this right here. So we already know it's going to factor to. It's going to factor to 2v plus 1 times v minus 2. And you know what? That's kind of another nice rule. If you've already factored something before, I mean, if your memory, I had that by memory, but it's short-term memory apparently, that, you live with it. And that, let's see, negative 4v plus 1v is, yeah. So that works here. All right, so we know what these answers are going to be, the same ones as these ones here. So v equals, I'm going to save time, v equals negative 1/2 or v equals 2. That was these ones. But it's a v, not an n. All right, 3 more problems, and I'm trying to finish in the next 7 minutes to get the hour 15. Probably one of my longer practice problem sets. I did warn you this would go on as long as it has to. All right, here we go. Also not set equal to 0, guys. So I'm going to subtract 4m both sides and add 1 to both sides there. Now nothing's going to combine here, right? It's not that these combine. I'm just going to rewrite it so that they're all set equal to 0 and in standard form. Like that. There we go. And these numbers are very pretty for us to work with as well. I already kind of see the answer in my head here. There's actually only one thing we're going to bother testing. 3 is a prime number, so we're going to do 3m times m. And 1 being a prime number, not only 1's not a prime number, but 1 only having one set of factors, 1 times 1, we know this will have to be a 1 and 1. Now, with 1 being positive and the negative 4 here, that's a minus minus. So this is the only possibility. Let's try it. Negative 3 minus 1. Negative 3 minus 1 is negative 4. There it is. So 0 product property, either 3m minus 1 equals 0. Add 1, divide by 3, you get m equals 1/3. Yes, that's how fast I do that part. Generally, I don't even write that part for myself. Or if m minus 1 equals 0, m equals 1. You write what you need to write, but you're getting to the same solution set. All right, last two problems here. We have 6r squared, so not equal to 0, so let's go ahead and let's add 2 to both sides there, so plus 2 plus 2. And we're going to go ahead and get 6r squared minus 3r minus 3 equals 0. Hey, I have a common factor of 3 now. Let's go ahead and factor that out. 3 times 2r squared minus 1r minus 1 equals 0. Very small numbers. In fact, I think we had a plus here, but we had this kind of factorization before, didn't we? Right here, 2r squared minus. So it's going to be very, very similar to this. The sign's going to change. We can play with it again. I don't care. The numbers are small enough. It's not going to matter. But 2r squared minus 1r minus 1 equals 0. So once again, this is a factorization because you won't always know that that's there. So 2r times r. 1 is some sort of 1 times 1 thing. Is this a plus and this a minus, or is it a minus and plus? Let's find out. Negative 2 plus 1 is negative 1, and there it is. So that equals 0 there. If 2r plus 1 equals 0, r is negative 1/2. Subtract 1, divide by 2, r is negative 1/2. Or if r minus 1 equals 0, add 1 both sides, r is 1. Hey, yeah, if you're good at doing that part and you don't want to show your work on it, go ahead. But you set them equal to 0 and solve. That hasn't changed. This is my 11th and 12th problem doing it. That's why I'm not going there. And finally, number 24. So we have this already factored, but it's set equal to 9. Here's what you don't do. There's no such thing as the 9 product property. I don't say either 8x plus 7 equals 9 or x plus 1 equals 9. We don't deal with it that way. I've spoken to my students very heavily about the idea here. This only works for 0. You have to set it equal to 0. And you have to get it in standard form set equal to 0 and factored. So what do we do here? Well, you have to set it equal to 0, get it in standard form, and factor it. And you might say, Mr. Robinson, it's already factored. Yeah, but it's a different factoring set equal to 9. This problem takes a little bit more to do. We actually have to, see, I got to move this 9 over, right? I got to subtract 9 over here. And then I'm going to get 8x plus 7 times x plus 1 minus 9 equals 0. Now, you can't use 0 product property now anymore. This may be a product, but now we have a difference. We have to get this into just a product set equal to 0. We can't have just this, which means we actually have to distribute. We actually have to FOIL. We have to actually distribute this out, get that in standard form, combine the negative 9 with anything that we can if possible, and then factor what's there. And guess what? It might be a way different factorization than this. I don't know what it is. I haven't seen it. So I'm going to go ahead and distribute. We got 8x squared plus 8x plus 7x, that's plus 15x, plus 7, and then minus 9 equals 0. 7 minus 9 is negative 2, and we get 8x squared plus 15x minus 2 equals 0. All right, now we have to factor this, and now we do it just like any other problem that you had there. So standard form set equal to 0, no common factors. Let's deal with the with the other things there. So will it be some sort of form of 8x times 1x, or will it be some sort of set of 4x times 2x? If you know me, if you've listened to what I had to say before, then you might know what this is. You can pause this for a second and think about it without calculating anything else. Think about it, and I'll tell you in about 4 seconds. Okay, you ready? 15 is an odd number. These both are evens. If you multiply evens by anything, you get evens. Even plus even is even. It can't be these right here. Not even going to bother. Not even going to bother. All right. Now, 2, thankfully, is just some form of 2 times 1. So, could I put 2 here? No. 2 is a common factor with 8. So, I'll try a 1 here and a 2 here. Now, I'll put plus and minus. I don't know if these are the right spots, but I do know as long as I get a 15 of some sort, positive or negative, that I did test the right thing. So, here we go. Only one I'm going to bother testing. Negative 16 plus 1 is negative 15. All right. Right number. Wrong spot in plus and minus. Switch the minus and plus. We're good. There it is. All right, so there's the factorization. So we have factored this and compare the factorization of what we had before with 8x plus 7 times x plus 1 to this, 8x minus 1 times x plus 2. It is not the same thing, clearly. It's not even close. There could have been a possibility that had 4x and 2x. I mean, it couldn't based on what we said, but, we didn't know that before. Oh, let me do this fast. If 8x minus 1 equals 0, x is 1/8, add 1, divide by 8 to both sides. Or if x plus 2 equals 0, x equals negative 2. All right, and there it is. Now, I'm surprised with myself. I suppose. I didn't know these problems beforehand, but I'm surprised with myself that none of these problems actually happen to have... See, I wanted one with a 4x and 2x. That means you would have had two different answers that were fractions, because you would have had to test both of them that way. It seemed like always one of them had the 1r, the 1x, the 1 whatever. None of these had a fraction on both answers, did they? No, they didn't. So that means we always had... that's too bad. But anyway, guys, that ought to do it for this one. This was a nice long one. I'm at the 1 hour 15 minute mark. So it went on as long as it had to. I hope you learned something about the mental factorization and the strategies involved. They are so important because it's not just guess and check. It's educated guess and check. It's trial and error, and it's testing only what you have to, or what you should bother testing with. Sometimes I test and I say, that won't be it anyway. And you can tell. Sometimes I got down to just 1 or 2 things to test, and that's it. That ought to do it for this one, guys. This is Mr. Robinson. Thank you so much for watching. And the more I talk about things like that, the more you're going to kind of hear them that way. Anyway, take care.